Starting with the classical shell theorem, you have a sphere or a circle which has an even distribution of mass all the way around. And because of that, the mass effect from one side propagates all the way across to the other side. And if you end up doing the math all the way around, the two sides cancel each other out. And it ends up being nothing, so that every point inside that shell doesn't experience any gravitational force, as though the shell and the element mass wasn't there at all. Now, if instead we say that there is a minimum to gravity, and we're not necessarily talking about a minimum, it could be a minimum force, a minimum curvature of space, whatever your version of gravity you're thinking of, but if there's a minimum, then the effect from that right side doesn't reach all the way across to the other side, which means there's a region over there that doesn't feel the pull to the other side to balance it. And this happens all the way around the shell, in all directions. And it also happens at the same time all the way around the shell, which means that effectively inside that shell there's a region that if you're, say, outside that red, then you would feel the pull toward the outside edge of the thing, because you're not feeling the other direction. It's not balancing anymore. And again, it's not just the one direction. It actually happens in all directions all around. So if anybody outside that is going to experience a pull toward the outer one in that direction, that is the direction toward the closest shell. So if they're on the left, then they're getting pulled toward that left shell. If they're on the right, they're getting pulled to the right shell. If they're on the top, they're getting pulled to the top shell. Continue that all the way around the circle in all directions. Now, the other side of this penny is that this could also happen if there's a time element, in that if the gravity from one side of the shell hasn't yet had time to propagate all the way across the shell to the other side, at which point the piece on the other side would move toward, again, its shell. So on the left, it moves to the left, at the bottom, it moves to the bottom, going all the way around. But if, say, the piece on the right hasn't had time to propagate this gravitational influence all the way across to the piece on the left, then past or more left than that red shell area will experience a pull of gravity away, even if it otherwise would have been balanced. It's just that gravity hasn't had time to propagate that far yet. And if we consider the implications of either one of these on the interpretation of the redshift of distant things and the expansion of the universe, then we might be able to not need to invoke dark energy at all. We might, just might, be able to do it with either minimum gravity or just the limited amount of time it takes gravity to reach one side or the other, and thus that distribution ultimately resulting in expansion. The difference would be that it would be an expansion in the mass getting distributed away, not an expansion of additional space itself. And it also means that stuff inside that shell of time or minimum gravity is still being attracted toward each other, so it's condensing there and expanding further out from that, depending on the distribution of the mass density and where that line ends up being drawn out in the cosmos.